Hello everyone, and I want to welcome you all in an exciting tutorial come demo about a computer vision project. So lately I've seen some computer vision related programs where mostly all the programs would basically do object detections like cars, person, all sorts of different projects that can be used for maybe inside factories, on traffic junctions, or other places where it can detect different things or maybe get a count of those things. But what I thought was maybe I can try something slightly different. I'm not sure whether this is already implemented or maybe in progress somewhere else. But the idea which popped up in my mind was, what about if we just don't do the object detection, but uh, maybe find a more elaborative scene description? For example, let's say when two people are walking on a busy street. So if you show this scene to a CCTV camera and ask the program what is happening, so this program can basically describe exactly what all things are there. Like for example, the objects, the people, what kind of clothes are they wearing, what are they doing, the interaction between them, overall the setting of the scene, like just like a human who is describing the scene best of his ability. So without wasting any more time, let's jump to the programming part, and I'll explain you how I have built this and a high level architecture of the things, the libraries, the code, and I won't be going in detail of the code, but just a very high level architectural and high level components that I've used in the application. Okay, so let's start with the front end part. The front end is basically pretty simple. It is just an index.html file with some CSS styles applied, along with a JavaScript file. It's a pretty basic setup, nothing fancy here. Nothing, there's nothing like some React or Angular app. It's a very simple set of index file style with CSS and along with a JavaScript file. Now I'll just open up the front end, which I have deployed on Vercel. So Vercel basically comes handy in here where you can just, deploy the app, the front end in a single click. So that part is pretty simple. Now over here, if you see, uh, there are certain sections in here. For example, image, webcam, and CCTV, RTSP. Now this is the look and feel and the the setup of this front end is made in such a way to kind of replicate a sort of behavior where when there is a production level app where when this kind of thing is running, and then there would be a different client on which a user can basically monitor what kind of log, what kind of things are being sent from the CCTV auto monitor, app. So this is not an entire exact implementation of that same thing, but somewhat a kind of POC for that kind of setup. So that is why now the thing that front end is doing, it is simply taking frames and sending it to the backend. Now, how backend is working and what is happening there, I'll come to that part later when we'll go to the backend part. So this is now those frames which the front end is sending, that could either be an image or frames from a camera feed or from a CCTV feed. Now, how it works is it basically takes every stream or every video is basically made up of certain frames. So it takes those frame. When I said those, not it just take one frame at a time, which and converts it into a JPEG blob and sends it to the backend through a fetch call. Now over here where we for the video part, the video is basically in a video element, and the canvas, there is a hidden canvas element which basically takes those frame and then sends it to the backend for uh, through a fetch call, like I mentioned earlier. So I'll now this is the front end part. This is how it looks. Now we'll go to the backend part and see how what is happening there. All right, so let's start with the backend part. But before that, I would like to do a small recap of what the front end is doing. Front end is merely sending the frames or image to the backend, and it is the job of the backend to do the interpretation using certain thing it has. Now, this backend is implemented on a Google Colab notebook, which is a code written in Python. The backend server is written using the Fast API. Fast API is a popular framework, a Python framework, which is used for implementing server code or any certain other things as well. Now, since when that server runs, because it is running on my personal Google Colab account, so it is kind of equivalent to a local server, though it's not actually running on my local machine, but it is kind of like that because it's on my personal account. Now, in order to make that server available to the front end, what I will use is something called as Ngrok. So Ngrok is basically a tool which makes your local server, which is running on your local system, available to a public internet. Because it's the way it works is it creates a kind of tunnel from your local system and exposes your server to the public internet. So using that the combination of fast API server and the ngrok, there are certain endpoints which are written in the server, and these endpoints are basically exposed to the front end. And in order to get make the ngrok thing work, uh, generally one would have to go to the ngrok web application, register themselves there, and then you will receive a token from ngrok, and using that token you can basically implement things like these, where if you are running something on your local system, so it can be made available on the public internet. And that token which I have got from the ngrok, I have basically stored it in the secrets in Google Colab, which it will pick it up from the code. The next important component of this backend is the VL model, which is the vision language model, which basically does the interpretation of any image or picture. Uh, this is a Qwen VL model, which is actually a comparatively small 3 billion parameter model. So we will use this Qwen model to do the interpretation. So how it works is when the backend sends a frame, which is like an image frame. Frames are basically whenever there is a video, so that video is basically made of certain number of frames. The most standard number of frame for a normal video is like it consists of 20 frames per second. Although we won't be sending all the frames, but we'll just send one frame in every 15 seconds. And that frame, when the backend receives that frame, so there is a Python library called Pillow. So that Pillow basically loads that image and then sends it to the Qwen model along with the prompt that we have provided in the Python. Although we have made sure that we can send that prompt as well from the front end, so you can basically modify it to suit certain scenario, because you cannot send hard coded prompt every single time, because it depends on what is the video about. But just for the demo purpose, I have put one single prompt that what is the as you can see here in the configuration. So describe in detail what is happening in this image, include people, their actions, and expressions, objects, interactions, and the overall settings. So this for demo purpose, this will follow this general prompt, but we can basically customize it using based on whatever the video is or what, let's say if you want to customize your needs. So when the Qwen model response is generated uh, using based on whatever image which was given to it, that response is then made available through one of the endpoint, which is a description feed. So uh, then the front end, I'm sorry, not the description feed, commentary feed. So we have a component in our application which is specifically for showing whatever commentary is being generated by the Qwen model. So this component then shows all the response which is generated, and then it does that every 15 seconds. Now the reason why uh, I've set this parameter to 15 seconds because when model takes some time to generate the response. So if that time window is not sufficient enough to, if it basically overlaps the generation window, so you won't be getting a proper response, which I initially observed during, because initially what I tried was I gave it a 3 second time duration. Like uh, I made that uh, time duration in such a way that it needs to generate, it will accept one frame every 3 seconds, and I expected it to generate a response and send it to the backend, but it kind of generated the same response when, although there were different scenes in front of the camera, but it kept generating the same response again and again. So I had to debug the whole thing, and then uh, when I debugged it using common sense, like 3 seconds is not sufficient time for this model to generate a proper response. So we need to expand that time window. So then I went on with 15 second. Anyways, 15 second is a pretty good enough time window to keep a watch on certain kind of scenario. Now, since this Qwen model is an BL model, it need to be run on the T4 GPU. Now, the T4 GPU is available under Google Colab free plan. So you can basically use this T4 GPU to run this whole notebook. Now I'll be showing the demo of this whole thing. All right, so I have connected my Google Colab notebook with a T4 GPU and ran all the code cells which are there. So at the end, we have this API, this fast API server running with the Qwen model loaded, and this is the this is the Ngrok URL which is made available by the Ngrok. Now this URL is going to act like a backend URL to which the front end will connect. Now the front end basically looks like this. Although this is not the front end that I'll be showing for the demo. I've opened this on my mobile camera. So what I will do, I will have to copy this backend URL, which is the Ngrok URL, provided in the API base URL along with the API key. So once we provide both the API base URL and API key in the mobile browser as well, I can show it to like this. So it will show this Tesla T4 connection here, and through this we can make sure, yeah, that the backend is up. Now what we will do, I will open the commentary page. Although this commentary page is based on the session, and this session which is open on my desktop browser is a different one, and we don't need this one. So I will connect it using my mobile a browser session, which I need to change it from here, which will be XVDS2 CA56B, and I just need to hit enter. The session has changed, and this is the session from my mobile browser. The API and things are already there. Then what I will do, I will go to webcam, the camera section, and I will open. Okay, backend is reachable. Now what I will do, I have this Jim Corbett book with me. I'll show it to you. I will point my camera towards this book, and let's see what generation it does. Let me first start the camera. Start auto view. I've kept it pointed towards the book. Okay. I will just stop. Okay. So as you can see, let's go through the response that we've got. The image appears to be a close-up of a book cover of a promotional material featuring a tiger's paw. The background is predominantly black with a dark brown stripe running horizontally across it. The tiger's paw is prominently displayed in foreground with its claws extended outward. The paw has a mix of orange fur and the white fur, as you can see. And just to let you know, guys, I haven't finished this book yet. Uh, Anyways, the paw has a mix of orange fur and white fur, typical of a tiger's paw. The text on the image is partially visible and seems to be part of the title or a subtitle. The visible text includes orbit. This actually missed the C part in large bold letters, which might be the name of the author or the main subject of the book. Below that, there is another line of text that reads Eaters of Kumaun. I think I might have missed the man eaters of Kumaun, suggesting that the book might be about tigers or wildlife in the region of Kumaun. In the bottom right corner of the image, there is a small blurred object that appears to be a toy or a figurine. So it actually also caught this thing. This is actually a small soft toy which actually belongs to my wife. Uh, I don't know why it's kept here, but it actually caught that as well. And uh, there's a small blurred object, okay, stuffed animal, but it is not clearly identified due to blurriness. Overall, the image suggests that the context of the book or promotional material is released to tigers, specifically those found in the Kumaun region, and possibly involves themes of survival or exploration. So as you can see, if we keep the camera on, it will keep generating the responses, whatever is in the front of the camera for every 15 seconds. As you can see, the Qwen model generates really uh, good and descriptive, interpretation of the images that it receives. I've tried this with some other model as well, but I haven't got this kind of detailed description as the Qwen does. So now coming to the part, what we can do with this thing. So basically, if we connect a CCTV camera with this, uh, with this kind of setup, and the camera, the CCTV is kind of always, most of the time it is pointing at a static scene. So we can use that camera to keep, like, to do an automatic monitoring of something or someone. Let's say, for example, if there is a patient in hospital and we want to keep a watch on the patient, maybe, if they go restless or there is some kind of urgency required in that by that patient, we can monitor that. Or maybe uh, there are some, in India, there are many shops which are prone to for burglary. And if you want to keep an eye if the, no one tries to break into the shop, you can use this, this kind of setup to keep an monitoring throughout the night. So if you want to know more details about this thing, the actual code that I've used in the Google Colab, then do let me know in the comment section. I will post this on my GitHub repo, and I'll also post the front end code if you want it, and then you can, maybe go through it. Okay, thanks for staying put and good luck.